Welcome to my messy workbench. Today I actually cleaned up a little bit this area because, unlike on the spectrum analyzer, we'll be playing around with the oscilloscope and the power supply. So my project here is I have a Kenwood TM-D700, the American version, and that has the capability to do APRS, but it needs a GPS module for that, and that's not built in, so that's my ultimate goal. But to power the GPS module, I will need 5 volts. So in the car, obviously, we have 12 volts, and so we need to convert 12 volts to 5 volt. And I have these adjustable converters that can convert the voltage, step down converter, and the buck converter. And right here is the product number. It's a 3148 PS, and it uses that little chip there. Is the LM2596, and that's what we have right here. And this module is actually, I bought that a longer time ago, and notice on the internet the newer module have now a little bit more components on them. I did look at the spec of this buck step down adjuster, the LM2596, and it doesn't, in their sample diagram, it doesn't need the extra components. So let's hope that this works out even without the components. So instead of just building this step down converter into my final system, I'm gonna test it out here on the bench first. Oh yeah, if you're interested on what components are missing, so right here, the V in, okay, I oriented it right. There we have a capacitor, and here we have one. So that's 100 microfarad. We have a 220. On the output side, it has a 220 microfarad, and we have a 220 as well. Both of them are 50 volts, so that's good because you can go all the way up to 40 volts, but we are going to run it at 12 volts and 5 volts, so that's not a big issue. Right here is your little potty, which we have here as well. That inductor we have as well. This is this monster here. There is your diode, which we have right here. So what we are missing is this resistor and this resistor with the LED. So that just lights up the LED if there's power. So we really don't need that. That little resistor is for the feedback loop. I don't know why that one is needed here. Apparently it also should work without it, and we're gonna find that out. So let's go ahead and set up this here, feed it with 12 volts from the power supply. There I can also see the current draw then. Over here I'm gonna use the oscilloscope just to measure the voltage, and we see how clean the voltage is. Let me set this up and I'm coming back. So I've set up my power supply at 12 volts, hooked it up to the step down converter, and have the multimeter hooked up to it, and also, just for fun, the oscilloscope. So let's go ahead and turn that guy on. We have now 12 volts on, and it draws pretty much nothing. The one thing is we don't have a load here yet either. So we get right now 3.5 volts. So I want 5 volts though. So let's go ahead and adjust that. We look over here, don't really see any ripples or anything major there. So can investigate that a little later. Let's get this up to 5 volts first. You want to go 5 volts exact. I don't know if that makes sense. That would be 5 volt exact. So now let's figure out something about the load. So hold on a second. Okay, now I have some paper here for you. So what we want to know is we need a load right here. So if we look at our formula, we have the voltage over resistance times the amperage. So we know the voltage, right? So we have 5 volts on the output, and on the load, the GPS module that I'm planning on using, I think it had 40 milliamps or something like that. But right now I just go with a power resistor right here. So this is a 50 ohm 100 watt power resistor, and so we have 50 ohms and we don't know the current. So now we can figure out the current. So we divide 5 by 50 and simple thing, so that's 1 over 10, which is 0.1 amp. So that will be the current going through it. If we would like to know how much power that is, wattage, we can go to the other formula. That's the power over, what was it, voltage and current. That's it. So now we know the voltage, which is 5 volts, and the current, which is 0.1 amps, and we multiply that and we get 0.5 watts. Okay, so that's actually a decent load for us. Not a huge load, but a realistic load with what we will be running. So let me go ahead and stop the power here and set us up. Voila, we have set that up. So right now it's a little bit of wire mess. I have the alligator clips right here, pull off the multimeter ground, and the alligator clips go into these 2 wires of the resistor, and on that right here I pull the positive, and then these 2 connectors are for the oscilloscope. So right now we have 0 volts, and let's go ahead and turn this whole thing on and see what happens. So we did calculate, how much amps did we calculate? It should draw 0.1. Oh, because this is 12 volt there, obviously it will draw a different amperage there. But on the wattage we said 0.5 watts, right here, and the wattage is 0.72, so you can see there's kind of a loss on it. Although, to be correct, we would need to measure really the current that we're running through here. But anyway, so right now we have 5 volts still, so that's looking good. Let's just try it out. So I'm gonna go over here and do the fine tuning. Yeah, let's go 1 volt down and 1 volt up. So we are 12 volts. Now I'm at 11 volts, 10 volts, 11 volts, 13 volts. Yeah, it's keeping it nice and stable. So that's good to go. So I think we are good with this adjustable DC to DC converter for 5 volts. The one problem that I saw is this old model that I have, which is working totally fine. It does not have holes through the board. So I need to figure out how to mount that. Do I want to find safe places where I can drill holes in? Do I just want to stick it on? Since it's going to be in the car, I definitely want it so it's secure. Heat doesn't make a problem or anything. So I have to think about it. Also could solder it on top of a PCB board, potentially. So, not sure yet. Till next time, when I work on the other components and combine everything.